Earth's seasons. In this lesson, we're talking about the effects of Earth's rotation, Earth's tilt, the effects of Earth's revolution, the tilt and direct sunlight, and then lastly, we're going to bring everything together and discuss why the seasons occur. Now, the interesting thing about this lesson is that it is a huge misconception among most people. So hopefully we're going to clear some of those up today. How your lesson works. Text that is bold and underlined is blank on your student copy. When you see it, pause the video and copy it into your notes. Whenever a video is available, you will see the video icon. Refer to your additional resource document to find the correct video link. While you're watching the video, take a few jot notes on the main ideas that are covered. Mine's on seasons. So what I'd like you to do is I'd like you to pause the video and answer these three questions. Number one, why is it cold in the winter and hot in the summer? Number two, what time of year is the Earth closest to and furthest away from the sun? And number three, what about the places near the equator? Why is their temperature pretty much constant throughout the year? So pause the video, answer these three questions as best as you can. Don't worry about being right. Don't look it up. Just try your best to answer the questions using the knowledge you currently have. So referring to that last question, what I'd like to point out is Pontianak, Indonesia, which is located right along the equator. You can see it highlighted in red on the right-hand side. What you'll notice is that the temperature, the average temperature, is pretty much the same throughout the year. It goes all the way up to 33 and all the way down to 31. So it's pretty constant. And you can also see the lows. It goes all the way down to 23 and all the way up to 24. So we pretty much have a constant temperature throughout the year. That's what I'm referring to when I'm talking about the places near the equator. How is this place pretty much constant throughout the year, whereas places not on the equator show different seasons? So first up, let's take a look at Earth's rotation. Rotation simply means spinning an object about its axis. So in regards to Earth, it's spinning counterclockwise. And one rotation of Earth takes 24 hours. Earth's rotation causes half the planet to face towards the sun during the day and the other half to face away from the sun, and that's at night. As the Earth rotates, the sun continually illuminates a different part of the surface. So the first thing you got to keep in mind is that half of the Earth is always illuminated and the other half is always dark. The dark side, that's going to be night. And the lit side, that's going to be the day. And as the Earth rotates, different parts of the Earth receive sunlight. That's why the sun rises and then the sun sets. Earth's tilt. Earth is slightly tilted on its axis, about 23.5 degrees. And you can see it measured right here. So that's the 23.5 degrees. This tilt is the main cause for the seasons, and we're going to come back to that. But it's very important that Earth is tilted. It's not straight up and down. Effect of Earth's revolution. So we talked about Earth's rotation, that's spinning about its axis. Revolution means the movement of one object around another object. So for instance, the Earth moves around the sun every 365.25 days. And this allows us to see different constellations during different seasons because we're in a different part of the sky. You might see constellation A while you're over here, and you'll see constellation B while you're over here. This change in position along with the tilt creates the seasons. So I talked about the tilt being the main cause, the revolution is the other cause. But combined, that's how we get our seasons. So what I'd like you to do is I'd like you to pause the video and using the diagram on the bottom, explain how the tilt and the revolution of the Earth around the sun causes the seasons. Again, to the best of your ability, not expecting you to be right, just write down what you think is the correct answer. Now that we've explored a little bit about the Earth's revolution, tilt, and rotation, I'd like you to revisit these three questions. Have a look back at your answers and see if they've changed. So let's talk more in depth. The tilt, as I said, was the main cause. The tilt of the Earth is about 23.5 degrees, and it causes different parts of the Earth to receive different amounts of direct sunlight. What do we mean by direct sunlight? Well, if the sun was over here, direct sunlight would be towards the northern hemisphere. So that would be direct sunlight. It's hitting it directly. On the southern hemisphere, that's going to be our indirect sunlight. It's going to hit it indirectly. It's going to be a little bit more spread out. So the rays aren't hitting it directly on, it's hitting it a little bit more spread out. So this is going to be indirect, and this is going to be direct sunlight. People on the equator, however, are going to receive approximately the same amount of direct sunlight all year. Therefore, their temperatures are mostly constant throughout the year. If you live right along the middle, so the middle is right there. If you live right along there, as the Earth rotates and revolves around the sun, you're pretty much going to receive the exact same amount of direct sunlight all year round because your position relative to the tilt of the Earth stays pretty much the same. So what I'd like you to do is pause the video and open the simulation. Once you have the simulation open, I'd like you to research what your latitude is. So once you've figured out what your proper latitude is, place your person at that latitude. So for instance, I put my person right there. Observe how the light strikes our person during January, March, July, and September. Those are sort of the middle of the main parts of the seasons. And then sketch your observation. So this is the example right there. In the space provided on the next slide or in your notes, and include your average temperature for your city during those months. So you're gonna have to look that up as well. So you need to look up your latitude, your average temperature, and then I want you to sketch out what you see using the simulation. Now for where I live, this is what I found. In January, my person is up here and is receiving what's called indirect sunlight, like I talked about before. And as a result, you can see that my sun rays are very slanted. That's going to be our indirect sunlight. Conversely, in the summer, in July, I'm receiving direct sunlight. That's this guy right there. And you can see my rays are much more up and down. I'm going to receive a lot more direct sunlight here than here. This is going to be indirect sunlight. And you can see during March and September, spring and fall respectively, it's somewhere in the middle. We're receiving some direct sunlight, but not as much as during the summer. And it's the amount of direct sunlight that we receive that determines our temperature. And then just to reiterate, when we're comparing winter and summer in the Northern Hemisphere, you can see in the winter, we have indirect sunlight, and in the summer, we have direct sunlight. And that means hotter, longer days. The tilt in direct sunlight. The more direct sunlight an area gets, the warmer it is. So in what season in North America tilted towards the sun? In what season is North America tilted away from the sun? And in what seasons does the tilt not really affect temperature? So I want you to take a look at this diagram and answer these 3 questions in your notes. So let's check your answer. During June, July, and August, it's summer in North America and winter in South America. This is because North America is tilted towards the sun, more direct sunlight, and South America is tilted away from the sun, less direct sunlight. So this is what we're talking about right here. This is the summer months right here for North America. And you can see all the direct sunlight we're getting. 1, 2, 3, 4, 5 beams of light compared to 1, 2 in the Southern Hemisphere. So that's why we're going to get winter down here and summer up here. During December, January, and February, the seasons are reversed because North America is tilted away from the sun, less direct sunlight equals winter, and South America is tilted towards the sun, more direct sunlight, summer. So again, North America gets 1, 2 beams of sunlight, so that's going to be winter. And South America, or the Southern Hemisphere, is going to receive 1, 2, 3, 4, 5, making it summer because you're getting more direct sunlight. So again, I'd like you to pause the video and I want you to open this simulation here, number 3. Make the inclination angle 23 degrees, that's the angle of the Earth's tilt, and trace the sun's path. Record your observations of the average daily temperature and then sketch the sun's path for both winter and summer in your notes. Now let's trace our situation here. There's our house in the summer and our house in the wintertime. And what you'll notice in the summertime is that the sun goes much higher in the sky. It does something like this. In the wintertime, the sun takes a much lower path. It does something like this. This is going to be 12 noon, and this is going to be 12 noon. But what you'll notice is that the time here is going to be much bigger than the time here. That's why we're going to have longer days in the summertime. So in the summer, you get longer days because the sun spends more time in the sky. It takes longer to go up here and around than it does to go up here and around. So in the summer, not only do you get more direct sunlight and more heat, but you also get longer days. Where I live, in the summertime, the sun sets usually around 9 to 9:30, and in the wintertime, it can set as early as 4:30. So summer versus winter, let's review. In winter, the sun doesn't get as high in the sky, and therefore we see it for less time, shorter days, and we receive less direct sunlight. It makes it colder. In the summer, the sun takes a much longer path across the sky, and therefore we see it for more time, longer days, and receive more direct sunlight. Makes it hotter. Keep in mind, too, that if the sun is in the sky longer, it has longer to heat the surface, again, contributing to more heat in the summertime. What I hope you got from this lesson is that summer and winter isn't determined by the distance the Earth is from the sun, but by the amount of direct sunlight that the Earth receives from the sun. And that concludes our lesson on the seasons.